Welcome to EC 107, Economics 1, Unit 1, The Capitalist Revolution, Lecture Video Part 2. In Part 1, we've already seen the intended learning outcomes of this unit. In this second of the 3 mini videos for Unit 1, we're going to be considering in more detail the technological revolution, which we have seen is associated with the idea of the hockey stick growth that we observed in Part 1. We're defining technology as a process that uses inputs to produce an output. For example, the inputs that would be needed at different periods of time to enable people to light their homes or their streets or their communities. And by reducing the amount of work time it takes to produce the things we need, such as light, sustained technological changes, which were beginning in Britain from about 1650, allowed sustained increases in output and in living standards measured by GDP per capita. And in this part 2 of Unit 1, we're going to be considering some of the areas of activity important to people's living standards, where technological changes were beginning to be sustained and were enabling people and societies to increase average living standards. The most remarkable scientific and technological advances occurred more or less at the same time as the significant upward kink in the hockey stick in Britain, especially after the middle of the 18th century. So we're going to be seeing this hockey stick picking up not just economic growth, but technological advances and changes across a variety of different aspects. So consider, for example, the case of light. In the figure, the vertical axis is measuring lumen hours per hour of labour. What lumens means is the extent of brightness or lightness of the generation of light. In fact, 1 lumen is approximately the amount of brightness in 1 square metre of moonlight. The vertical scale is picking up a ratio scale, so you'll see that the horizontal bars running along from the vertical axis are measuring 10, 100, 1,000, 10,000, etc. So each bar is representing a tenfold increase in what's being measured on the vertical axis. The horizontal axis is starting off at 100,000 years ago and moving along the right, getting closer to the year that we're in now. And what you can see is that, again, there is this hockey stick-like shape in which nothing really changes over a period of 100,000 years until the very last 200 or 300 years, and then there's a vertical-like takeoff. The circle in the middle of this diagram is showing you the more detailed changes that have taken place between 1800 and the year 2000, and all of that, of course, is being concertinaed into this very small area on the actual horizontal axis. So this is picking out the great detail, where we see that from 1800 to around 1840, we still have this flat, very low increase in the productivity of labour producing lumen hours. And then from around the mid-1800s, that really takes off and is growing clearly exponentially along this ratio scale. So, for example, today the productivity of labour in producing light is about 500,000 times greater than it was among our ancestors around the campfire. So we're really thinking about campfire kind of technology as being one in which we've probably got 10 to 20, maybe perhaps 50 at most, lumen hours per hour of labour, as people are chopping at trees and burning wood and producing really rather little light for their efforts, and that doesn't really change over this vast amount of time until the takeoff period occurs from around 1800 to 1850, etc. And this is all happening at the time of the Industrial Revolution. So how are we defining the Industrial Revolution? Well, we're thinking of it as a wave of technological advances which started in Britain in the 18th century and which transformed an agrarian and a craft-based economy into a commercial and an industrial economy. And here's just some pictorial examples of the kinds of fire we're talking about. So for many hundreds of thousands of years, fires were producing really rather little light based on campfires. Then we begin to move into a period of time where there's more investment in the production of light, and so we get tallow fats, which are producing light by candles with wicks running through the centre of them. They're producing rather little light, but the tallow is making them last for longer, and so there's an efficiency gain there. What then happened was that, as we'll see over the next couple of slides, that domestic lighting then began with gas lights in the home. This is a scene from a film called Gaslight, directed by Alfred Hitchcock, starring Ingrid Bergman, and Gaslight's the title of the film, and it's based on the idea of housing having gas supplies into it and light being produced from gas lights in the home. Today, at the flick of a switch, we have electricity generating light within the home, and in the period associated with the Industrial Revolution, coal mining was an important factor, and the way in which light could be used underground in order to illuminate coal excavation was an important step, and the invention of the Davy lamp, which we're seeing here, as a safety feature in the production of light underground in an arena in which highly inflammable gases make the risk of fires very significant underground, and so the safety lamp was an important development in the different stages of the Industrial Revolution. Not everyone can flick a switch and have light in their home, and one mode of lighting, which we see even in the current day in economically less developed or privileged societies, is associated with the Litre of Light project launched in 2011 by the My Shelter Foundation. And this scheme uses plastic bottles filled with a solution of bleach water, in the diagram you can see an image of that, installed into holes made in shantytowns' corrugated iron roofs. And then this solution within the bottle refracts the equivalent of 55 watts of sunlight into the room, essentially enhancing the extent to which natural sunlight illuminates the interior of a room. So to this day, there are still huge variations in the way in which people are able to illuminate their domestic surroundings. I'm not going to read through all of this slide. You can do so by putting the video on pause, but here's just an image and some description of the way in which gas lighting was used not only for domestic lighting purposes within the home, but also in the development of street lighting, which was a way of making communities much safer, and that was also based on gaslight technology in the 19th century. Indeed, throughout much of the 19th century, gas lights were simply naked flames of varying shapes, depending on the type of burner, and if any of you have studied chemistry at any point, you'll have come across the Bunsen burner, and developments made by the inventor of the Bunsen burner, Robert Bunsen, were an important feature of the way in which gas lights were made safer for use in the home and in communities. Nonetheless, electric lighting gradually began to replace gas through the first half of the 20th century, so that today domestic lighting in the UK is largely based on electricity. So we've talked about technological progress and the hockey stick of that progress in the generation of lumens per hour. Another example of technological progress which reveals this hockey stick change is in the speed in which news travels between different communities. The vertical axis in this figure measures the speed of news travelling at a rate of various miles per hour over time, and we're going back to a period of about 1,000 years ago. And what you can see here is that for that period of time, for most of the last 1,000 years until around 1800, news was travelling at a rate of just 1 mile per hour. And there are examples of documents which reveal this, for example, in the way in which news travelled between Egypt and Italy between the years of both 50 to 222 in the Common Era. We see that 1 mile an hour rate of transmission of news. And that was still true in the year 1500, where documents revealed that news travelling of events occurring from Venice, travelling to Damascus or Alexandria and Lisbon and Palermo, all of these events, the news of them was travelling at around 1 mile per hour. Walking pace is typically something like 3 miles per hour, but over very long distances, you can't really walk at a constant rate of 3 miles per hour. Rest and recovery times are needed, and so that's why the rate of transmission of news falls to about 1 mile per hour for all of that period. That includes with travel assisted by horses or other animal transport. By 1800, we have had some slight improvement, so that news of the Battle of Trafalgar, for example, off the coast of Spain, was reaching London at a rate of just short of 3 miles per hour. By the middle of the 19th century, in 1857, news of the Indian Mutiny against British forces reached London from Delhi at a rate of just short of 4 miles per hour. And then around 1860, news of Lincoln's election reaches the west coast of the US from Washington, D.C. at a rate of about 7 miles per hour. And news of Lincoln's assassination 5 years later travelled across the US at a rate of 12 miles per hour. So improvements are fairly rapid in this period. Something like every 3 to 5 years, there's a doubling in the speed of the travel of news across distances. Today, the transmission of information around the world is occurring at close to the speed of light, but information, as we've seen then, has not always travelled that fast. And these events that we're talking about in the US reached London across the Atlantic Ocean much more slowly, of course. Indeed, it took about 13 days before the Times newspaper of London was reporting on Lincoln's death after the event had occurred. So, technological revolution from around the 1700s was occurring with this hockey stick-like exponential growth in the generation of light, in the speed at which the news travelled, and in a whole variety of other industrial processes, and we'll go on to discuss those in part 3 of this Unit 1. But whilst increased production and increased efficiency in production associated with technological revolution were enabling an enhancement of average living standards in societies where technological revolution was occurring, there are also negative impacts to be taken into account. And increased production and the population growth that goes along with it affects the environment in various ways. So one of the global impacts of this is by global climate change. This diagram charts what has been happening to global temperatures on average over a period of time from 1,000 years ago to the current period. The vertical axis measures deviations from mean temperatures in the period 1961 to 1990 in degrees Celsius. So taking the year 1000 as a basis, what you see is a fairly long-term secular fall in global average temperatures to around the period of 1700, and then a steady increase in the average global temperature, and something like a rather exponential growth in temperatures in the more recent period. So again, this diagram charts something similar to the hockey stick growth that we've seen in average living standards and in measures of industrial production and technological change. Indeed, on the very day of writing this slide, the BBC is reporting a recording of 54.4 degrees Celsius at Death Valley in California, being the highest ever official recorded temperature on the planet. Economic growth then is associated not only with increases in average living standards, but also with environmental impacts and also with changes in economic inequality, as we saw in part 1 of Unit 1. And one example of the way in which economic growth and inequality interact with each other and with environmental change is borne out in an article by George Monbiot in the Guardian newspaper of September 2019, where he explains relationships between changing inequality, changing patterns of consumption behaviour, and the changing nature of environmental impacts of consumer behaviour. In the final lecture video of Unit 1, we'll be going on to discuss the nature of the capitalist revolution, to define capitalism, and to look in more detail at the relationship between